So exam type, one of the most important question, expected question we can say. F of d is given to us. Auxiliary equation is f of m equal to 0, m square plus 1 equals to 0, m square equals to minus 1, m is equals to plus or minus root minus 1 plus or minus 1 9. So m is equals to 0 plus or minus 1 9. Alpha and beta are there, so yc equals to e power alpha x c1 cos beta x plus c2 sin beta x. Now we'll write yp. Yp equals to 1 by d square plus 1 into x square sin 2x. Now we'll write imaginary part of 1 by d square plus 1, imaginary part of x square. This sign will replace by e power 2ix. 2 is there, aix. See, if cos is given to us, we can write real part of this. So when x square is there, x square as it is, sin 2x is e power 2ix. If cos is there, e power 2ix. Imaginary part for sin, real part for cos. This e power ix is cos ax plus I sin ax. This one. Now, imaginary part of this e will take outside. 1 by, if we will take e outside, d becomes d plus a, d plus 2i. Same, which type we have? Fourth type question. E is there, we will take e outside. Whenever we will take e outside, e power a will go to d plus a. A is this one, x coefficient. Then this one as it is, imaginary part of e power 2ix. Simplify this one, a square plus b square plus 2ab plus 1. Imaginary part of e power 2ix 1 by I square is minus 1, so this is minus 4. D square minus 4 plus 4id plus 1 x square. Imaginary part of e power 2ix 1 by minus 3 plus d square plus 4id. See, in third type what we have done, when x square is there, we have to take common, constant common. First we will take minus common. 3 minus of d square plus 4id. Then we will take 3 common. Directly minus 3 also you can take common. Minus 1 by 3, imaginary part of e power 2ix 1 minus d square plus 4id by 3 x square. Now we can write this one as minus 1 by 3, imaginary part of e power 2ix. Expand till power 2. 1 minus x, 1 plus x plus x square of x square. Four id by 3 plus a square plus b square plus 2ab divided by square of 3 is 9. Now the degrees other than power 2 is ignored. This one and this one are ignored. 1 plus d square by 3 plus 4id by 3 plus this is minus 16 d square by 9 x square minus 1 by 3 imaginary part of e power 2ix. 1 into x square is x square. 2 times derivative of x square is 2. 1 time derivative of x square is 2x. 2x into 4 is 8x. 2 times of derivative of x square is 2. 2 into 16, this is 32 by 9. Once we get the value of this, we have to replace imaginary part of full form of this one, cos 2x I sin 2x, x square plus 2 by 3 minus 32 by 9, you can simplify. 9 and 3 LCM is 9, 3 times 9, 6 minus 32, 26 minus 26 by 9 plus 8xi by 3 minus 26 by 9. These two simplification. Now we can guess imaginary part. If I'll multiply cos 2x to all these three terms, I contain value is 8x by 3 with this. Eight x by 3 cos 2x is our imaginary part, or you can write as it is imaginary part of multiply all the values cos square cos 2x 8x by 3 cos 2x 26 by 9 cos 2x plus x square sin 2x I. This is I square, this is minus 8x by 3 sin 2x, then I minus 26 by 9 sin 2x of I. So minus 1 by 3. Imaginary part means I contain part. Cos 2x, this contains x square sin 2x, then this value minus 26 by 9 sin 2x. So this is our yp. So solution will be y is equals to yc plus yp. Time consuming, but the thing is definite question for your final exam. If you check 2 to 3 questions, you will get correct idea regarding this. F of d equals to d square plus 4. Auxiliary equation is f of m equals to 0. M square plus 4 equal to 0. M square equals to minus 4. M is equals to plus or minus root minus 4 plus or minus 2i. So yc equals to e power alpha x c1 cos beta x plus c2 sin beta x. Then yp. This will write 1 by d square plus 4 x into cos 2x. Once we find x and cos 2x or x square cos function, that time we will write imaginary part of e power, not imaginary part, real part of e power I 2x we will write. 2ix also you can write. Now because it has e, we are taking e outside, e power 2ix into 1 by x coefficient will add with d plus 2i plus 4 into x. Here we will write real part of real part of e power 2ix 1 by a square plus b square plus 2ab plus 4. Now this becomes fourth type, d square minus 4 plus 4di plus 4. Real part of 1 by d common, d minus 4i minus 4i plus d. See, taking constant in previous problem, what we have, 3 terms were there, constant we have taken first. Here we have only 2 terms, so take d common. Now go for this one, like previous method. What we used to do, 1 plus x inverse or 1 minus x inverse formula. So taking minus 4i common, 1 minus d by 4i into x. Real part of e power 2ix 1 by d minus 1 by 4 outside. This is 1 by I, 1 minus d by 4i inverse minus 1 by 4. Real part of e power 2ix 1 by d 1 by I 1 plus d by 4i. Expansion is only one time. Here what we have done, 1 minus x whole inverse is 1 plus x square plus so on. Because x is degree 1, so only we take 2 terms here. Minus 1 by 4, real part of e power 2ix 1 by d 1 by I 1 into x, 1 by di 1 is 1 by di plus 1 by di into d is dd cancel. This 1 we can write minus I square to remove the denominator I. dd and I is I square. I square is minus 1. This is minus 1 comes here 4. I single I cancelled. Real part of e power 2ix minus I into integral of x is x square by 2 minus 1 by 4x. Now a real part of this, I'll write full form of this, cos 2x plus I sin 2x minus I into x square by 2 minus x by 4. For real part, we can multiply directly both of them. I am multiplying this, minus I x square by 2 cos 2x minus x by 4 cos 2x. This one I square minus I square is plus 1 sin 2x x square by 2 minus I into sin 2x into x by 4. We need real part. So what is real part here? Now we will not write real part. We will take real part here. Minus x by 4 cos 2x plus x square by 2 sin 2x. Then if we will multiply, this is yp. Y is equals to yc plus yp is our general solution. Most important question. This is d square y plus 3dy plus 2y, all having y common. So f of d equals to d square plus 3d plus 2. Auxiliary equation is f of m equal to 0, m square plus 3m plus 2 equal to 0, 2 plus 1, m common, m plus 2, plus 1 common, m plus 2, m plus 1 and m plus 2 equal to 0. M equal to minus 1 or m is equals to minus 2. Yc equals to c1 e power m1x plus c2 e power m2x. Now most important thing, we have f of d equals to 1 by d square plus 3d plus 2 into x into e power x sin x. In fourth type, what we have done, e power x question means e power x taken outside, e power x outside. So this becomes d plus 1 square plus 3 into d plus 1 plus 2 x into sin x. After doing fourth type, we will get that fifth type inside it. D square plus 1 plus 2d plus 3d plus 1, 3d plus 3 plus 2 x sin x e power 1x 1 by d square plus 5d plus 6 sin x. Now this is our question. Now what we will write? E power 1x is anyhow answer. 1 by d square plus 5d plus 6. We will write here imaginary part of e power, this is 1ix, x into 1ix. Now again we have e here, so we will write e power 1x, imaginary part of e power 1ix. We will take this I outside, so we have 1 by d plus 1i whole square 5 into d plus 1i or I plus 6 into x. E power x, imaginary part of e power ix into 1 by d square plus I square plus d 2di plus 5d plus 5y plus 6 of x. E power x, imaginary part of e power ix 1 by d square minus 1 plus 6, d square minus 1 plus 6 is plus 5 plus 2di plus 5d plus 5y. We will write constant first. Phi common. One plus d square plus 2di plus 5d plus 5y divided by 5. This 1 by 5 outside, this one 1 plus d square is no use, so that's why I am not taking that one. 2di plus 5d plus 5y by 5 inverse of x. E power x by 5, imaginary part of e power 1 9. This one is 1 minus x. 1 minus x. One into x is x. Derivative of x is 1. Derivative of x is 1 minus 5x. E power x by 5. Imaginary part of you should write, then write full form of this, cos x plus I sin x, x minus 2y by 5 minus 1 minus ix. Now if you are good enough to take imaginary part, directly also you can take imaginary part, but better thing is to multiply this. X cos x minus 2y cos x by 5 minus cos x minus I x cos x, this is over, then I x sin x, I square is minus 1 plus 2 by 5 sin x minus I sin x minus I square is plus 1 x sin x. E power x by 5, imaginary part of this. So we will take coefficient of I minus x cos x plus x sin x minus sin x. If you want to simplify, you can simplify or you can extend this. Y is equals to yc plus yp. f of d equals to auxiliary equation f of m equal to 0, m square equals to minus 1, m is equals to plus or minus root minus 1, yc equals to c1 e power alpha x c1 cos beta x plus c2 sin beta x. Now yp equals to 1 by d square plus 1 x square e power 2x plus 1 by d square plus 1 x cos x. So yp1 equals to 1 by d square plus 1 x square e power 2x. This is fourth type question. When e power 2x is there, we will take e power 2x outside. 1 by, while taking this e power dx outside, d is taken, that d plus 2 plus 1 with x square. So e power 2x 1 by a square plus b square plus 2ab into x square. So e power 2x 1 by 5 plus d square plus 4d. Now 5 common. 5 common, 1 plus d square plus 4d by 5 x square. So e power 2x by 5, 1 plus d square plus 4d by 5 inverse. So 1 plus x whole inverse is 1 minus x plus x square, so on. E power 2x by 5, 1 minus x means these values both will get minus sign, plus x square. Square of this a square plus b square plus 2ab divided by pi square. E power 2x by 5, 1 minus d square by 5 minus 4d by 5. Big degrees, you can eliminate this. 16 d square by 25 of x square. So e power 2x by 5, 1x square minus 2 times derivative of x square is 2, 1 time derivative is 2x, 2 4 is 8x, derivative 2 time of x 2, 16 times 32 by 25. This is yp1. For yp2, 1 by d square plus 1 x into cos x. X and cos x function is there. So that time what we will do? 1 by d square plus 1 real part of e power x into e power 1ix. Then we will take real part of e power 1ix outside. If we will take this outside, x coefficient will be added to d of x. So real part of e power 1ix a square plus b square plus 2ab plus 1 of x. Real part of e power 1ix 1 by d square minus 1 plus 1 cancelled plus 2id of x. Real part of e power 1ix 1 by d common, d plus 2i. Because we can't take a constant common here, so we have to take d common. Then real part of e power 1ix into 1 by d separated, 2i common, 1 plus d by 2i of x. So real part of e power 1ix 1 by d, 1 by 2i, 1 plus d by 2i inverse. Now that 1 by d and 2i, 2id we will multiply here. 1 by 2id, 1 by 2id into d by 2i of x. Now here 1 by d 1 by 2i. 1 plus x inverse is 1 minus d by 2i of x. Now we will multiply. Real part of e power 1ix 1 by 2id into 1 1 by 2id into d by 2i of x. This will be real part of e power 1ix. Here I is there in denominator. So if I is there in denominator, we will take this 1 as minus I square. Here d cancelled, 1 by 4i square. I and I is cancelled. Real part of e power 1ix minus I by 2d minus into minus plus 1 by 4x. Real part of e power 1ix minus ix minus I by 2, this is 1 by d, integral of x square by 2. This 1 by 4 into x is x by 4. 1 by d into x, this is treated as integral of x is x square by 2. Now real part we will write, this e power ix will write as full form cos 1x I sin 1x. So this is minus x square I by 4 plus x by 4. Real part of, we will multiply these two, minus x square by 4 cos x into I plus x by 4 cos x minus x square I into I is I square is minus 1 sin x by 4 plus xi sin x by 4. What is real part we find here in this one? Without I part is real part, this and this one. So x by 4 cos x plus x square by 4 sin x. This is yp2. So y is equals to yc plus yp1 plus yp2. So follow 2-3 times. You may find some simplification errors in this one. So you can simplify according to that and comment.